So, we hear it all the time, right? Artificial intelligence is totally changing the game in science. It promises to sort through these huge mountains of data and help us make discoveries faster than ever. But, as we start to hand over more and more of the work to our digital helpers, a really big question comes up. Are we also handing over our scientific integrity? And believe me, this isn't just some far-off theoretical problem. One researcher's recent experience gives us a pretty stark warning, and maybe a path forward.
So let's start with a story. And it's not about some big breakthrough, but actually a pretty significant breakdown. An event at one of the biggest, most prestigious AI conferences in the world basically sent a massive warning shot to the entire scientific community.
Now, what's really telling is the official response they gave. So after it came out that AI had just hallucinated, totally made up, fake citations in research papers, the reaction from the conference board was, well, it was kind of shocking. They basically said that even with fake references, the paper's content isn't necessarily wrong. Think about that. That suggests you can separate the data from the conclusion, which that goes against the very core of scientific integrity.
And we're not talking about just one or two papers that slipped through the cracks here. No, we are talking about over 100 papers that were accepted with fabricated references. This wasn't just a typo, it was a huge systemic problem that showed a really casual attitude about a fundamental part of doing research.
So, here's the bottom line. This relaxed approach, this attitude of who cares, as Dr. Stevance from Oxford University puts it, is an incredibly dangerous precedent to set. It's a huge red flag telling us we desperately need a better ethical framework before we let AI become the co-pilot for, well, all of science.
Okay, so to really get why this is so important, let's pivot a little. Let's move from the problem to a real-world scientist who is facing a literally astronomical challenge. And this is where Dr. Stevance, a computational astrophysicist, comes into our story.
Her job is honestly just fascinating. She hunts for supernovae, these massive stars that explode at the end of their lives. And why does she do this? Because those explosions are the cosmic factories that create all the elements that make up everything. You, me, this planet. The only catch is these explosions are only visible for a few weeks, so it is an absolute frantic race against time to find them. And this right here just brilliantly shows you the scale of her problem. On a really clear, dark night, you might look up and see a few thousand stars. Pretty cool. But her tool, the Atlas Sky Survey, sees 1 billion bright sources every single night. It would take her an entire year just to look through one night's worth of pictures by hand. It's just impossible.
And this brings us to the two giant pressures that are pushing scientists toward using AI. First, just overwhelming, immense amounts of data. And second, there's simply not enough time. You've got deadlines, grant applications, and just the basic fact that there aren't enough hours in the day. For a lot of researchers, AI doesn't feel like a luxury, it feels like an absolute necessity. So, faced with this exact problem, Dr. Stevance didn't just accept things as they were. Instead, she developed her own personal code. 3 really clear principles for using AI ethically and responsibly in her work. And honestly, it's a blueprint we could all learn from. It all starts with this one key question. It's a question every single researcher should ask themselves before they even think about using an AI tool. It's not about how fast it is or how convenient. It's about the future. It's about asking, will the work I do today be understandable, verifiable, and something that the scientists of tomorrow can actually build on? And our answer to that big question comes down to these 3 simple principles. Number 1, the data behind the AI has to be open. Number 2, resist all the hype and just use the simplest tool that actually gets the job done. And number 3, always be skeptical. Okay, so let's break that down a bit. All right, principle 1 takes on this kind of sneaky trend called open washing. A company might call its AI model open source, but if you can't get your hands on the data it was trained on and really check it out, then you can't truly reproduce or understand its results. And for science, if it's not reproducible, it's just not reliable. Period. Principle 2 is all about avoiding what's called intellectual debt. It's really tempting to use the newest, fanciest, most complex AI model because it sounds impressive. But if that model is a total black box, you're creating a roadblock. Future scientists, or heck, even you in a few years, might have no idea why it worked. And that basically creates a dead end for that line of research.
And the risks of that intellectual debt are very real. Just imagine your entire research project depends on some third-party AI service. What happens when they decide to triple the subscription price? Or they update the model, and all of a sudden your results are completely different. Or what if the company just disappears? You lose all control. You lose what she calls scientific sovereignty.
And principle 3, be skeptical, really gets to the very heart of what science is supposed to be. It's super easy for an AI to find a pattern and give you an answer that looks right. Just stopping there, that's called confirmation bias. But the scientific method demands more. It means you see that it works, and then you have to ask, okay, but why does it work? And then you have to actively try to break it to find its limits.
So what does all of this mean for the future? It means that as our tools get more and more powerful, the human scientist actually becomes more important, not less. We have to be the ones who guard the scientific method.
And Dr. Stevance is really honest about this. She admits that she feels that FOMO, that fear of missing out, that anxiety that she's going to be left behind if she doesn't use the latest AI agent to help write her papers. It's a pressure we can all relate to, but she argues that just chasing the latest trend can't be the goal.
And this brings us to the most important point of this entire explainer, and it's captured perfectly in this one quote. AI is an amazing tool. It can help do the science. It can run the calculations, find patterns, make things way faster. But it cannot understand the science. That is still the unique and absolutely essential job of the human scientist.
So this leaves us with one final, really vital question for the future of science. As we bring in these incredibly powerful but often murky tools, are we actually building a solid foundation of knowledge for the next generation, or are we just creating a pile of results from black boxes that can never be truly understood or verified or built on, and in the end, does that make discovery itself just an illusion?